So you came here for me to talk about SCD, or you're just my teacher evaluating my final grade. If you are, hi! It really doesn't matter at this point. So, welcome. Now, the big money question here today is, what is sickle cell disease? SCD, or sickle cell disease, is considered one of the most prevalent red blood cell diseases in the US, affecting over 100,000 Americans, as it is a genetic condition, in which the shape and function of the hemoglobin molecule in red blood cells are changed. Let me get this straight. SCD, or sickle cell disease, affects over 100,000 Americans. Not even in the world, just Americans alone. But getting back to topic, you may be wondering, what is hemoglobin? So, hemoglobin is basically a protein that is in charge of transporting oxygen throughout the body. And SCD causes any affected blood cells to break down early, potentially causing anemia to occur. Now, going a few steps back, hemoglobin is basically a protein. So in the red blood cell, we'll take the circle, and yes, it will be the red blood cell. Inside the red blood cell, there's a protein. And this will be represented by this blue squiggle. Yes, a blue squiggle. This is in charge of transmitting oxygen all throughout the body, which basically allows us to live. So without it, that's going to be a problem. Moreover, since these blood cells are inflexible when they're affected by SCD, they're able to be trapped in small blood vessels, allowing no blood to get to tissues and damaging organs. The most damage to the spleen, which is right above the stomach. Who was the most magnificent person that discovered this disease? Sickle cell disease was first discovered and described on November 15, 1910. By this dude, just drawing right here, smiley face. His name was Dr. James Herrick. He was a cardiologist. He first discovered sickle cell disease in a dental student who had what we now know acute chest syndrome. Herrick described the red blood cells as sickle-shaped or crescent-shaped, giving its name early on. So imagine if a normal red blood cell looked like this. That's what it normally looks like. Now, what he saw looked like this. This is not normal. That should not be happening. However, this is normal. So in the next 15 years, so basically 1911, 1912, 1913, yada yada, all the way to 1925, more cases of sickle cell disease popped up, supporting the concept that this was a new disease. So imagine 1911, there are about 3 cases. Cool. 1912, maybe 7 cases. 1913 special year. 14 cases. Now imagine 1925, there are about 9 cases. The frequency of how many cases of sickle cell disease occurred in the years built on the fact that this was a new disease. Though Dr. James Herrick was an important person in finding what sickle cell disease first was, other researchers that contributed to research on sickle cell disease include upon Gillespie, Scriver, Waugh, and Linus Pauling. And though all of them contributed, Linus Pauling was kind of special because he became the first researcher to hypothesize that sickle cell disease might originate from an abnormality in the hemoglobin molecule. And with the power of editing, we now have a new clean slate. So what are the types of sickle cell disease? Because there just can't be one. So the types of sickle cell disease include hemoglobin, SC, SE, SS, or sickle cell anemia, which is the most severe type. Beta zero thalassemia, and beta thalassemia. So the reason why SS is the most severe, or sickle cell anemia, is because this contains both genes from the parents of hemoglobin S. Now, because I said that hemoglobin SS is from both parents, that means sickle cell disease is an autosomal recessive genetic condition. And this means that at least 2 copies of the normal gene, in this case, hemoglobin S, must be present in order for the disease to develop. So for other types of sickle cell disease, such as SC or SE, they already have one abnormal gene from one parent of hemoglobin S. However, the other gene, as you can see from C and E, this is another abnormal gene that contributes to how the child has sickle cell disease. So imagine if 2 parents are carriers of sickle cell disease where they have sickle cell trait, and they have hemoglobin AS. And we will be discussing sickle cell trait here too. So imagine if they were both carriers and they have sickle cell trait. Their children would have a 25% chance of being normal, a 50% chance of having sickle cell trait 2, and sadly a 25% chance that they actually have sickle cell disease. The 25% chance of being normal, that means that the child has hemoglobin AA, no health problems. For the 50% chance of sickle cell trait, that means they also have hemoglobin AS, just like the parents, which means that they do not have any health problems. However, they can pass on the gene of hemoglobin S, maybe with the possibility of having the child have sickle cell disease. And sadly, there's a 25% chance that the child has sickle cell disease with hemoglobin SS. Now, sickle cell trait is different from sickle cell disease primarily because it contains the gene for sickle cell disease, which is this part, hemoglobin S, but rarely the child has any health problems that sickle cell disease has. However, they can still pass it on, and with the child having sickle cell disease, like what's happening over here. Early signs and symptoms of sickle cell disease include but are not limited to 1. Jaundice, which is basically, imagine this is a hand. It is the yellowish color of the skin. Secondly, icterus, which is yellow in the whites of eyes. Third, fatigue or fuzziness from anemia. And lastly, dactylitis, which is the painful swelling of hands and feet. So imagine this is normally, or what the hand looks like. And it swells up. And it's also very painful. Over time, sickle cell disease can lead to infections, stunted growth, and numerous occurrences of pain called pain crisis. Sadly, sickle cell disease is a lifelong genetic mutation, but treatments are available. Treatments for sickle cell disease include non-steroidal anti-inflammatory drugs such as parenteral opioids or ketorolac. In addition, for vascular necrosis or when bone blood supply is disturbed and bone tissue can die, there are treatments such as bone transplant, bone reshaping, and also non-steroidal anti-inflammatory drugs. As of now, there is a cure, and that's bone marrow transplant. However, the risk is very, very high, so very few people actually take the surgery. One interesting fact about this genetic condition is that supposedly people with sickle cell trait, like this dude here with SCT or sickle cell trait, is protected against malaria such as falciparum malaria, which is very, very dangerous. That is caused by Plasmodium falciparum. So we have this other dude. Give a smiley face like usual. His name is JBS Haldane. He was the first person that presented a case similar to this, speculating that based on their DNA, the risk of death will be different for people when they're confronted by a parasitic organism, as you can see right here with the dude that has sickle cell trait and the malaria. Possible explanation for this is because hemoglobin S, which is right here, in people with sickle cell trait pushes for a biochemical change in red blood cells, having the possibility of also affecting the metabolism and growth of parasites like Plasmodium falciparum, though specific evidence of the process and reason is still vague. A possible explanation for this is because hemoglobin S in people with sickle cell trait, which is this dude right here, and his hemoglobin S is right here, pushes for a biochemical change in red blood cells. And this might have the possibility of also affecting the metabolism and growth of parasites like Plasmodium falciparum. Though specific evidence of the process and reason is still vague and argued now. Sickle cell disease is complicated, with the one cure for it currently being risky and rare to actually perform. However, the information we have today pales with what we knew about this disease decades ago. And that, ladies and gentlemen, if you're still here, is the end of the video. The sources I used will be in the description below or written in the next second or so, depending if I can actually work YouTube, but that is it. Goodbye.